Question number 6 is theory question. Streamline turbulent flow. Movement of people is structured, organized, disciplined. That's one way. Army. When they move in a disciplined manner. Civilians haphazard, random. Fine. So the basic difference is either the flow of people is organized or it is unorganized. Similarly, fluid is also. It can be very systematic, very organized, but it disciplined. Then it is termed as streamlined. If it is haphazard, random, unorganized, indisciplined, then it is termed as turbulent. First part. What is streamline flow? Streamline flow is flow in which every particle of the liquid follows exactly the path of its preceding particle. How many particles are marked? Yes. Say in a pipe, particles move along this line. Three particles are marked positions. This is P, Q, and R. This is P, this is Q, this is R. Suppose velocity at this point is V1. Velocity at this point is V2. This point is V3. So at present, there is one particle at this position. It is having velocity V3, say 10. When this particle Q will reach this position, it will also have the same velocity V3. Like in a group, say in a parade, you can predict that this group, if one group has done a particular action, the second one will follow the same. That means you can predict that when this Q reaches at R, it will have what velocity? V3. When this particle is at this position, its velocity is V1, and when it will reach, you are predicting, when it will reach Q, it will have velocity V2, and when it will reach at R, it will have velocity V3. So it is predictable only when it is organized, when there is some discipline. Once again, streamline flow is a flow in which every particle of the liquid follows exactly the path of its preceding particle. Q will do the same, what R has done. Particle number 2 will follow the same path. All particles, this is the particle R, it is following a particular track. The following particle will also follow the same track. That is why you can predict. Path of its preceding particle has the same velocity as that of its preceding particle while crossing through that point. 1 minute with you to write. What is a streamline? In this tube, particles follow a path. In steady or streamline flow, they follow a path. This path followed is termed as streamline. Path followed by particles in steady, systematic, organized flow is termed as streamline. 1 minute to write. One more question. What is a streamline? Path followed by particle in steady flow. Streamline properties. Yes, number one is what? No two streamlines can cross each other. Why? If you assume one streamline crosses the other one, then again at this point, what we're saying is particle will have two velocities. Tangent to this represents the direction of the velocity v1. Here it is v2. One particle cannot have two velocities at one point of time in space, at a point. That is why no two streamlines will cross each other. This is one. Two. If you draw a diagram, this is a pipe, one cross section, area is more, this area A1 is more than area at 2. If water enters at A1, leaves at A2, we draw streamlines for the same. That will mean what? Yes. At where area is more, the distance between the streamline is more. If area is less, distance between the two will decrease. Statement number 2. More crowding of streamline means high speed. Why? Crowding of streamlines means more speed. Reason is, if there is no storage to be covered, continuity equation to be covered. If there is no storage, there is no leakage, water entering, liquid entering is equal to liquid leaving to be covered. If velocity at this point is V1, A1 V1 is equal to what? Volume leaving at this point. A1 is more than A2. So V1 will be what? Less than V2. If you move from this position to this position, suppose area is half. Speed at this point 2 will be how many times? 2 times. Product of area and speed remains a constant. Volume entering is equal to volume leaving. Crowding of streamlines. So as you move from A1 to A2, crowding, more lines per unit area means what? More speed. Less crowding means less speed. 2 minutes with you to write properties of streamline. 2-mark question. Laminar. It is also more or less streamline, but it is in a channel. That is, in case of a river, movement is in form of layers. Upper layer, top layer moves with speed 10, next layer moves with speed 8, next layer moves with speed 6, and the lowest layer with a 0. If it is disciplined, organized, then it is termed as a laminar. 1 minute to write. 1-mark question, no numerical. Turbulent flow. This is exactly opposite to streamline. What was streamline? Disciplined, regular. Turbulent flow is what? Irregular flow, unorganized, random, haphazard. How? If water is flowing and suppose you have a pole here like a pillar supporting a bridge. When the water is flowing, it will hit this pole, pillar. Some of the water moves to the right, some of the water moves to the left. And if you see the top view, this is the pole. Water is flowing surrounding the same. As it moves, yes, at this point, it is a low pressure point. That is why eddies are formed, means irregular flow. Here the flow will be unorganized, haphazard. And many times, if you are on a bridge for a river case, you can have some sort of sound also. Fine. Why? Because this liquid moves from one direction, the other liquid moves from the second direction, they hit, collision takes place, and there is a noise. So the flow here is not organized, it is irregular, unorganized, haphazard. Such a flow, irregular flow, is termed as a turbulent flow. So, purpose of the article is whether the flow is disciplined or not. Regular, it is irregular. If it is regular, it is streamlined. If it is irregular, it is turbulent. 1 minute to write. B part of question number 6 deals with Reynolds number. All of you have one brand, Reynolds. Deals with what? Pen. It is after the same scientist. Because the scientist research was to find flow. And when you buy a pen from the market, what you see is flow. If it is regular, systematic, this is a good quality. If it is irregular, for example, 2 pens, pen number 1, pen number 2, this is pen number 1, this is pen number 2. Pen number 1 is regular. And this one you have ink here and here you don't have, again you have ink, again you don't have, it is irregular. So, companies can find out the value and can give you the quantitative value. Reynold came out with a number, that this number will give you an idea whether flow is organized or not organized. So, Reynold number is what? Reynold number is a ratio. Ratio of what? If NR represents Reynold number, it is equal to what? Yes, it is a ratio of 2 parameters. One, numerator, number of things are there. What is the value? Rho, density. Density of what? Liquid. D, dia of a tube. V, velocity. So it is rho d v. If there is a pipe in which liquid flows, property density, dia d, velocity v. This part is the inertia factor, you call this as, and inversely proportional to what? Eta. This material has another property, coefficient of viscosity, eta. This number, he said, will decide whether the flow is streamline or turbulent. Correction. Case 1, NR less than 2000 streamline. Case number 2, correction, NR more than 3000. If NR is less than 2000, flow is streamline. If NR is more than 3000, it is turbulent. If this number lies between 2000 and 3000, it is in between the two. That means it will change from streamline to turbulent. Discussion. Eta will try to do what? Yes, eta will try to decrease this number. That is why when you have honey and a spoon, you have honey moving out of the bottle, moving say onto another object, spoon, the flow is smooth. Why? Because eta is high, Reynold number is less. This number will decide whether the flow is turbulent or not. These parameters, inertia factors, the density, dia, velocity, they will try to increase Reynold number. That means they try to make the flow turbulent. Eta tries to make flow streamline. So, for a given liquid, if a speed is slow, for any liquid, if speed is slow, Reynold number is less. As speed increases, Reynold number increases and the flow changes from streamline to turbulent. 2 minutes with you to write Reynold number. Completed. If you keep on increasing the velocity, Reynold number will keep on increasing. The stage at which it changes from streamline to turbulent, that is the maximum velocity which is allowed. If you are above that velocity, it will become turbulent. That is what critical velocity for a given number. Numerical. Formula is NR is equal to rho dV by eta. We refer to numerical number. 9. Numerical is the flow rate from a tap of diameter 1.25 centimeter is 3 liter per minute. The coefficient of viscosity of water is 10 raised to power minus 3 Pascal second. Sorry, yes, PES second, we will take up the units, SI units. Characterize the flow. Means what? Given is what? Dia. Dia is how much? 1 centimeter. What else? Yes. Velocity and flow rate 3 liter per minute. Flow rate, volume flowing per second is 3 liter per minute. Eta 10 raised to the power minus 3 SI units. find NR. What is the use of getting a Reynold number? Its a value will give you whether the flow is streamline or turbulent. So Reynold number formula is given. It is what? Water. Liquid is water. Density of water 10 raised to power 3 kg per meter cube. Dia of the tube is given. How much? 1.25 into 10 raised to power minus 2 meter. Eta given 10 raised to the power minus 3. What is not known to you is speed. So step 1, how to find speed. Yes, volume flowing per second is equal to area into speed. For a given pipe, volume coming out is what? Area into speed. Area into distance is volume per second. Speed is distance by time. Volume flowing per second is given. How much? 3 liter. 10 raised to power minus 3 meter cube. 1 meter cube is 1000 liter per minute. 60 second is equal to, area is equal to what? Pi r square or pi d square by 4. V is equal to what? V is equal to 3 into 10 raised to power minus 3 divided by 60 into 4 divided by pi d square. Put this value of V in this equation. Put this value, this is say point number 2. Put this value of V here. Eta is already known to you. How much? Yes, what was the value of eta? 10 raised to power minus 3. So, in Reynold number, density was given, dia was given, eta was given. The only challenge was to find a speed. 1 minute for calculation. Find the Reynold number. Yes. Anyone? Approximate value is what? Reynold number comes out to be equal to what? Approximate value. Anyone with the answer, please? Yes? Approximately 5100. So if a Reynold number is approximately 5100, this number is more than 3000. So flow is turbulent. So competition questions, you have to find out Reynold number, and Reynold number you have to come out with whether this value is less than 2000 or more than 3000.